Okay, on to our next type of rotation, a rotational solid around the y-axis with two curves. Once again, this is going to be a washer problem. And once again, the key on all of these problems is just about finding the radius. We actually have two slabs, an outside slab, which can be considered all blue. I'm going to color it here too. And an inside slab, which we're going to take out of there. All we need to do each time is remember the volume of a slab is pi r squared h. The height is always going to be the thickness, and all we need to find are the inside radius and the outside radius. And we can use either approach to the problem. We can find the integral pi r1 squared minus r2 squared d. Let me just put h there for now because I didn't pick a direction h. Or we can do this two separate pieces, pi r1 squared h minus pi r2 squared h, where it's always upper minus lower. So we're going to go around the y-axis, which adds an extra layer to the problem. You can always reverse all the things and solve it out. I will do it both ways in this video. I can show you the first way. If you're fine after that, you can stop watching the video at that point. So what I'm going to do is I'm going to put the following two curves around the y-axis. Y equals 4 minus x and y equals 4 minus x squared. And I'm going to rotate that around the y-axis. What I'm going to try to do here, because I don't have it in front of me right now, so I'm going to try to see if I can do this problem without a calculator to begin with, and just see what's going on. So I know I'm going to be in quadrant 1, and the big key here is I'm rotating around the y-axis. I just have to figure out which direction I'm going to be going in. Here comes Grady again. Hello, Grady. I'm recording again.
Get the window.
Okay, I will help you with Angry Birds in a little while. Grady, go down and ask Haley. Go down to the basement and ask Haley. We'll take a look at it together in a little bit. Okay, what I see here is that I have a line and I have a parabola, like so. And if I were to graph them, let's look at a couple values. When x is 0 for the line, when x is 0, y equals 4. X is 0, y is 4. And how about when x is 1? When x is 1, y is 3. And I also like to look when y is 0, what is x going to be? X is going to be 4. So the line's going to look something like that. And now let's look at the curve. When x is 0, y is also 4. So they're going to meet at this point right here. The real question is, what are they going to be when y... Let's pick a point in the middle. Let's pick 1. When x is 1, y is 3. So they have the same value there. The question is it above or below? I actually know it's a concave down. So at this point I already know it has to look like this. I know it's concave down. It's got a negative sign. I could have put 0.5 in there, and I would have got an answer that would show me it was bigger. So I see where I'm starting and where I'm ending from. This is the region I want to rotate around the y-axis. Let's discuss what that would look like. Let's redraw it over here. Here's the region. There's the top. There's the bottom. When I rotate the blue around, I'm going to get something like this. And the line is going to look like that. So it's going to be some sort of big cup-shaped thing, which has, in the end, a giant hole in it, piercing it on down. So what I'm going to do is I'm going to find the volume of the upper curve, and I'm going to subtract out the volume of the lower curve. All I need to know are my radii. First thing I need to know is which direction am I cutting in. I'm cutting in the y-axis. So I'm going to do two separate integrals for this problem. So I know they're both going to be dy. Minus, I know they're both going to have pi. And I know they're both going to go from 3 to 4. The radius for the upper curve is parentheses 4 minus x squared, close parentheses squared. And the radius for the inside curve is also going to be 4 minus x, close parentheses, squared. Did I do that right? Oh, I don't think so. What did I do wrong? Right, the same thing that everyone does wrong when they're dealing with things in the y direction. Before you work the problem, that's why I always do this step, even when it's not necessarily necessary, is okay, this was y, the differential was y, so this becomes x squared, and this becomes x squared. So you have to remember, I need to get x by itself for each equation in order to solve it out. Everyone always jumps and tries to put that equation in there, and then just starts integrating away. So before I flip to the next page, can we figure out what x is for each of these? I can solve that one out. If I get x by itself, it becomes, if I bring the 4 to the other side, I get y minus 4, so x equals negative y plus 4. And I'm just going to find what x squared is in this one. It'll make my life easier. X squared equals negative y plus 4. So that gets my x's by themselves. That is Angry Birds. Good job. So into my equation, I'm going to fill those on in there. Pi from 3 to 4. X, so the parabola is on top, so that's going in first. So I know what x squared is. I don't have to get x by itself if I don't want to. I could have, it still wouldn't have caused a problem. Absolute, sorry, rather, parentheses y plus 4 dy, close, oh no, it should be close parentheses, minus pi, the integral from 3 to 4, x squared, and the other one is negative y plus 4 squared dy. So I'm going to rewrite that on the next page so I have room to work with it. And so it was pi, the integral from 3 to 4 of negative y plus 4 dy minus pi, the integral from 3 to 4 of negative y plus 4 squared dy. You can find each thing individually, or you could combine them all into one problem, which would be pi. And any approach is right. This is not necessarily a non-calculator. I'm just going to put it in. Negative y plus 4 minus negative y plus 4 squared dy. What I've done is I've taken out the radius part of each one. That's one radius. That's the other radius. Did I put them in backwards? Is it possible I put them in backwards? No, I put them in correct. Just making sure if I put them backwards, I'll get a negative answer, which would be the opposite of what I wanted to have. And I could put that in the calculator and get an answer. Or what I could do is simplify the problem, see if I can do it by hand. So this is negative y plus 4 minus, I've got to square this thing right here. If I'm squaring that, it becomes y squared minus 16y, because I'm just foiling. A squared, 2 of those squared. Sorry, we said negative 16. I meant to say 4 times negative y is negative 4y. 2 of those is negative 8y plus 16 dy. I could simplify the problem a little further. Look for like terms. So it's going to be, first I'm going to distribute this negative sign in. I'm going to distribute that into there the quick way. Make that plus, minus, plus, minus. So what do we have? We have negative y squared. And then I have an 8y minus y is negative 7y. I've got a negative 16 and a positive 4. So that's negative 12 dy. And then I actually have something I could work out and get a real number for. Not saying you would have to do this, but I'm just going to do this one out anyway. Let's go to the next page. Got to flip back and forth a couple times so I can remember it. 3 to 4 of negative y squared minus 7y minus 12 dy. I'm just going to verify I got those numbers right. There's my negative y squared. I've got, positive 8y minus y. That was my mistake from before. This should be positive right here. Thought I had something wrong. It's not a creamer. I found it. Unless you said it beforehand, then it does become one. And this is something I can very straightforwardly integrate. So it becomes negative y to the third over 3 plus 7 over 2y squared minus 12y. Integrate that from 3 to 4. It's not a common number of things they're going to give you, but this will give me the same answer as the calculator gave me. The big key on this problem was making sure I went in the y direction. If I really wanted to, I could have worked the problem the exact same way and switched everything, in which case I would have been looking at the regions bounded by x equals 4 minus y, x equals 4 minus y squared, and the x-axis. And the only difference in these problems is instead of later on in the problem getting y by itself, because you have to graph it, you initially get y by itself, and you end up with y equals negative x plus 4 for the first one, and you get y equals the square root of negative x plus 4 for the second one. And when they go in, the same math is going to come up in the problem as you saw on all the ones before. Key again, find the upper, square it, subtract the lower, square it, every time, every time.